there, welcome back. We're going deep today into data structures. They might sound kind of intimidating at first, but trust me, they're the backbone of so much of the tech we use. And honestly, once you peek under the hood, it gets super fascinating. We got some excerpts from a recent Algo Academy article called Should You Even Bother Learning Data Structures? And it's going to guide our deep dives today.
And let me tell you, the article makes a pretty compelling case
Right.
for why understanding data structures is totally worth your time. And it's not just for the hardcore coders either.
Right. The article really opened my eyes to just how much data structures impact our digital lives. But before we get ahead of ourselves, let's start with the basics. What exactly are e-data structures?
Well, think of them as specialized ways to organize information. Like imagine you have a massive library. If you just toss books in randomly, it'd be a nightmare to find anything right.
Oh, yeah, total chaos. I'd never find the book I was looking for.
Exactly. Data structures are like having a well-organized library catalog system. You've got different structures like arrays, linked lists, trees, graphs, each with its own unique way of organizing data and its own strengths and weaknesses.
So it's all about making information easily accessible.
That's a big part of it. But the article goes deeper, explaining how the choice of data structure can dramatically affect the efficiency of your code.
Okay, so how does that work?
Well, imagine you're searching for a specific contact in your phone. If your contacts were just a random jumble, you'd have to check each one until you found the right one. That could take forever. But because they're organized alphabetically, you can quickly narrow down your search.
Makes sense. So it's like using the right tool for the job. You wouldn't use a hammer to screw in a light bulb.
Perfect analogy. Choosing the right data structure can be the difference between code that runs smoothly and code that just crawls. The article gives this great example of searching through a list versus using a hash table.
Yeah, I remember that. Something about hash tables being way faster.
Exactly. A list is like checking every book on a shelf.
Yeah.
One by one. A hash table, on the other hand, is like having a map that tells you exactly where each book is located. It lets you jump straight to what you need.
So it's like having a secret shortcut. But the article emphasized that data structures are about more than just finding things quickly, right?
Absolutely. Learning about data structures is like learning a new way to think. It trains you to think algorithmically, which means breaking down problems into smaller steps and finding the most elegant and efficient solutions.
That sounds incredibly useful, even beyond coding.
It is. These skills can be applied to so many areas of life. Think about planning a trip, organizing a project, or even just figuring out the best way to pack your suitcase. Algorithmic thinking helps you approach any complex task in a more strategic and efficient way.
So it's like a mental workout for problem solving.
Exactly. And here's the really exciting part. The article points out that data structures are essential for understanding and working with all sorts of cool advanced technology.
But what kind of technologies?
Think artificial intelligence, machine learning, designing efficient databases. These fields all rely heavily on data structures. They're the building blocks for creating complex and sophisticated systems.
Wow. So it's like learning the alphabet before you try to write a novel.
Perfect analogy. You need to understand the fundamentals of data structures to be able to work with these advanced concepts effectively.
Okay. I'm definitely seeing why this is important. But the article also mentioned that understanding data structures can actually make your code cleaner and easier to work with, right?
Absolutely. It's all about organization. When your data is well organized, it makes your code more modular and easier to maintain, especially when you're working on large projects with other people.
So it's like having a tidy workspace.
Yeah.
Everything has its place, so you're not scrambling to find things.
Exactly. A well-organized code base is a happy code base.
Yeah.
Well, let's be honest. A well-structured code base can make you look like a rock star in the eyes of your colleagues or potential employers.
Okay, I have to ask, how big of a deal are data structures when it comes to getting a job in tech?
Let's just say they're pretty high on the list of things tech companies look for. Interviews often include questions about data structures and algorithms because they want to see if you can think critically and solve problems efficiently.
So it's like the secret handshake to get into the club.
You could say that. But beyond the interview process, understanding data structures makes you a more competent and versatile developer. You'll be able to write better code, which is valuable in any tech role.
So it's not just about checking a box on a resume. It's about developing a valuable skill set.
Absolutely. It's about leveling up your coding abilities and becoming a more well-rounded developer.
Okay, I'm officially on board. But I am curious about what kind of transformation I can expect as I dive deeper into the world of data structures. Will it really change the way I think about coding?
The article says it can be quite a shift in perspective. Instead of just writing lines of code, you'll start thinking more strategically. Like a chess player planning their moves, you'll start to analyze how different data structures impact the performance of your code, which is something the article refers to as time and space complexity analysis.
That sounds pretty intense. What exactly does that mean?
It's about understanding how much time and memory your code needs to run. It's like figuring out if your code is a speed demon or a memory hog.
So it's all about making my code lean and mean.
Exactly. And once you start thinking about code in this way, you'll be able to spot potential bottlenecks and optimize your code for better performance.
I can already see how that would be incredibly helpful. So we've talked about how data structures can boost efficiency, problem-solving skills, and even open doors to exciting new fields. But what about those mind-blowing real-world applications the article mentioned? I'm ready for some aha moments.
All right, let's start with something you probably use every day: social media. Ever wonder how Facebook suggests friends?
Oh, I was just thinking about that. It's always a mix of people I know and people I should know.
That's the power of graphs at work. Social networks use graph data structures to represent connections between users. Think of it as a web, with each person being a node, and each friendship being a connection between those nodes.
So it's like mapping out a network of relationships.
Exactly. And by analyzing the patterns in this network, Facebook can figure out who you might know based on your existing connections.
That's so cool. I never realized data structures were behind. Something as seemingly simple as friend suggestions. What other real-world examples can you share?
Well, how about the file system on your computer?
Right.
Ever wonder how your computer keeps track of millions of files without getting everything mixed up?
It's a miracle I can ever find anything.
Well, thank a tree structure for that. Computers use tree structures to organize files and folders in a hierarchical way, just like the branches of a tree. This allows your computer to quickly locate and access the files you need, even if you have a ton of them.
Wow, so my meticulously organized downloads folder is a testament to the power of trees.
Exactly. And here's another example you'll appreciate: the magical undo button. Ever accidentally delete something and breathe the sigh of relief when you could undo it?
The undo button is a lifesaver.
And it's all thanks to a data structure called a stack. A stack works on a last-in, first-out principle. Imagine a stack of plates. You can only add or remove plates from the top.
So each action I take is like adding a plate to the stack, and hitting undo is like taking the top plate off.
Precisely. That's how the undo function keeps track of your actions and allows you to reverse them one by one.
That's so clever. I never realized something so simple could be so powerful.
And we can't forget about autocomplete and spell check, features we rely on every day. They depend on a special data structure called a trie, which is specifically designed to work with text and patterns.
A trie. What's so special about it?
Think of a trie as a super efficient way to store and search through words and prefixes. It's like having a dictionary that can instantly find all the words that start with a certain set of letters.
So every time I misspell a word, and my phone helpfully suggests the correct spelling, it's a trie working its magic.
Exactly. Tries are the unsung heroes of text manipulation. And last but not least, we can't forget about databases. Imagine trying to find a specific piece of information in a massive database without any kind of organization.
It would be like searching for a needle in a haystack.
Databases rely on clever indexing systems to find information quickly, even in data sets with billions of entries. And guess what? These indexing systems often use a special kind of tree structure called a B-tree, which is optimized for searching and indexing large amounts of data.
Wow, it sounds like data structures are the secret ingredient behind so much of what makes our digital world work.
They absolutely are. And the best part is, once you start understanding these concepts, you'll start to see them everywhere.
I can't wait to start seeing the world through data structure colored glasses. But I have to ask, how do we actually go about learning all this stuff effectively? Is it just about reading textbooks and memorizing definitions?
That's a great question, and one that the Algo Academy article addresses directly. They emphasize the importance of a hands-on approach. You can't just read about data structures. You have to actually implement them.
So it's about getting your hands dirty and writing some code.
Exactly. Platforms like Algo Academy offer a ton of coding challenges that force you to think creatively with data structures. It's like a mental gym for your coding skills.
Sounds like a fun way to learn. What else do they offer?
They have structured courses that guide you through the learning process, step by step. And they even provide AI-powered assistance to help you if you get stuck. It's like having a virtual coding tutor by your side.
AI assistance for coding. That's incredible. And does Algo Academy also teach you how to analyze your code's efficiency, like we were talking about earlier, with time and space complexity?
They do. They help you understand how to analyze your code
Mm-hmm.
in terms of big O notation,
Hmm.
which is a way of measuring how the performance of your code scales
Mm-hmm.
as the amount of data increases.
So they're equipping you with the tools to become a coding optimization expert.
Exactly. And they even have resources specifically designed to help you prepare for technical interviews,
Yeah.
which, as we discussed, often involve data structures and algorithms.
So it's like a one-stop shop for all things data structures.
Pretty much. They provide a structured and supportive environment for learning, practicing, and refining your skills.
This is all fantastic information, but before we move on to part 2 of our deep dive, are there any other tips or resources you'd recommend for people who are just starting out with data structures?
Absolutely. One thing I always recommend is finding ways to visualize how different data structures work. Our brains are wired to process visual information, so seeking out diagrams, animations, or interactive tools can make all the difference in understanding these concepts.
That's a great tip. And are there any other resources beyond Algo Academy that you'd recommend?
There are tons of great resources out there, including websites, books, and online courses. One thing I would suggest is finding resources that resonate with your learning style. Some people prefer more visual explanations, while others prefer more hands-on coding examples. The key is to find what works best for you.
That's great advice. And as we wrap up this part of our deep dive, I just want to say I'm already feeling more confident and excited about tackling this topic.
That's fantastic to hear. And remember, the journey of learning about data structures is an ongoing one. The more you explore, the more you'll discover the incredible power and versatility of these fundamental building blocks.
I can't wait to continue our exploration in part 2. We'll be back soon to dive even deeper into the world of data structures. Until then, happy coding.
Welcome back to our data structures deep dive. We're about to get hands-on and see how these concepts translate into real-world problem solving.
Yeah, we'll be looking at some specific scenarios where choosing the right data structure can make all the difference.
So it's like taking everything we've learned and applying it to practical situations. Exactly. Imagine you're tasked with building a music streaming app, something like Spotify.
Oh, I use Spotify all the time. I can't even imagine how many songs they must have in their library.
Millions upon millions. And when you search for a specific song, you expect those results to appear almost instantly.
Of course. I don't want to wait around forever for the app to find what I'm looking for.
Right, that's the challenge. You need to figure out a way to store and organize all those songs so that searching is lightning fast. So how would you approach this problem?
Well, my first thought would be to organize the songs alphabetically, like a giant playlist.
That's a logical starting point.
Yeah.
But remember our discussion about efficiency. A simple list would mean searching through potentially millions of songs one by one, which could take a lot of time.
Right. That wouldn't be very efficient. So what's a better approach?
This is where a hash table really shines. Remember, it's like
Yes.
a super organized index that lets you jump straight to the information you need.
Oh, so you could use a hash table to link each song title to its location in the database.
Exactly. That way, when you search for a song, the app can instantly retrieve it without having to scan through the entire collection.
Wow, that's a game changer. So hash tables are like the secret weapon for super fast search functionality.
They're definitely a powerful tool for that. But let's go a step further. Imagine you also want to recommend similar songs based on a user's listening history. You know, those personalized recommendations are a big part of what makes music streaming so enjoyable.
I love those recommendations. They always seem to know my tastes so well.
And that's where graphs come into play. Remember, graphs excel at representing connections and relationships.
So could you use a graph to connect songs that people frequently listen to together?
Precisely. The graph can represent songs as nodes and the connections between them as edges. The more often two songs are played in sequence, the stronger the connection between them.
So if I listen to a lot of classic rock, the graph will recommend other classic rock songs I might enjoy.
That's the idea. The graph analyzes listening patterns and makes recommendations based on the strength of the connections between songs.
Data structures are like the invisible force behind so many features we use and love.
They're the brains of the operation, working behind the scenes to make our digital lives seamless and enjoyable. Let's switch gears for a second. And consider a scenario that involves a text editor.
Hey, like Microsoft Word or Google Docs?
Exactly. One of the most essential features of any text editor
Mm.
is the undo function. It's a lifesaver
Mm.
when you accidentally delete something or make a mistake.
I can't imagine working without the undo button. I rely on it constantly.
So how would you use a data structure to implement this functionality?
I think we talked about this earlier. It involves a stack, right?
Yeah.
Because it works like a pile of items where you can only add or remove from the top.
You nailed it. Each action you take in the text editor, like
Aish.
typing a letter, deleting a word, copying and pasting, is added to the top of the stack. This last in, first out principle allows you to reverse your actions step by step.
So each action is like a snapshot in time, and hitting undo takes you back to the previous snapshot.
That's a great way to think about it. It's like having a time machine for
Yeah,
your text edits.
this is making me realize how much we take data structures for granted. They're the silent heroes behind so many of the tools and technologies we use every day.
And as we've seen, understanding these concepts isn't just about writing code. It's about approaching problems strategically, thinking about efficiency, and finding elegant solutions. These are valuable skills that can be applied to almost any field.
Yeah, I'm starting to see data structures everywhere. Even something as simple as organizing my to-do list can be approached using data structure principles.
That's a great observation. How would you apply data structures to your to-do list?
Well, I usually prioritize my tasks, right? So the most important things go at the top of the list
Yeah.
and get tackled first. That sounds a lot like a queue, where items are processed in a first in, first out order.
Brilliant.
Yeah.
You're instinctively applying data structure concepts to your daily life. It's a testament to how these ideas can help us organize our thoughts
Yeah.
and approach tasks more systematically.
This deep dive is opening up a whole new way of thinking for me. I'm excited to see what other insights we uncover.
We're just getting started. There's so much more to explore in the world of data structures. And in the next part of our deep dive, we'll delve into how this knowledge can elevate your coding skills to a whole new level.
I'm ready to level up. Bring on part 3. We're back for the final part of our deep dive into the world of data structures.
And we're going to explore how this knowledge can transform you into a more powerful and efficient coder.
I'm ready for that transformation. We've already seen how data structures are the driving force behind so much of the tech we use every day, from social media to file systems.
We've even discovered how they can help us organize our to-do lists.
Right. But let's bring it back to coding for a second. How does understanding data structures actually change the way we approach coding challenges?
Well, one of the significant shifts is that you start thinking beyond just those individual lines of code, and you begin to see that bigger picture. You start thinking in terms of systems, efficiency, and elegance.
So it's like becoming an architect who designs intricate structures
Yes.
instead of just a builder who lays bricks.
Precisely. You develop a deeper understanding of how the choice of data structure can impact the overall performance of your code. You start to consider factors like time complexity and space complexity, which we touched on earlier.
Right. Those concepts were about measuring how much time and memory your code needs to run.
Yeah.
It's like figuring out if your code is a lean, mean machine or a resource-hungry monster.
Exactly. And as you become more comfortable with these concepts, you'll naturally start writing more efficient code from the get-go.
So no more writing messy, inefficient code. That takes forever to run.
And gobbles up all my computer's memory.
You'll be able to spot those potential bottlenecks and optimize your code for better performance right from the start. That's a game changer. And I remember the article mentioned that understanding data structures can even make debugging easier. That's something any coder would appreciate.
It's like having X-ray vision for your code. When you understand how that data is flowing through your program, you can pinpoint the source of errors much faster.
So less time spent scratching my head and more time spent writing awesome code.
Absolutely. And beyond. Just those technical benefits, there's also a huge confidence boost that comes with mastering these concepts.
I can imagine. It must feel amazing to know you have the tools to tackle any coding challenge that comes your way.
It's incredibly empowering. And speaking of tools, we can't forget about resources like Coco Academy, which we've mentioned throughout this deep dive.
Right. They offer those interactive courses and coding challenges that we discussed earlier. But what else makes Algo Academy stand out as a learning platform?
Well, one of the things I find most helpful is their AI-powered assistants. It's like having a personalized coding tutor available 24/7 to answer your questions
Yeah.
and guide you through those tricky concepts.
It's like having a coding buddy who's always there to help you out.
Exactly. And they also provide specific resources for preparing for technical interviews,
Right.
which, as we discussed, often involved data structures and algorithms.
So they're like a boot camp for aspiring coders, helping you sharpen your skills and prepare for the real world.
They provide a structured and supportive environment
Mm.
for learning and growth,
Mm-hmm.
which can be incredibly valuable, especially when you're first starting out.
This all sounds amazing. But I'm curious, is learning about data structures only relevant for aspiring software developers?
That's a great question, and the answer is no.
No.
While data structures are certainly foundational for software development, the problem-solving and analytical skills that you develop
Mm-hmm.
can be applied to a wide range of fields.
So even if you're not planning to become a coder, this knowledge can still benefit you
Yeah.
in other areas.
Absolutely. Think about fields like data science, finance, research,
Yeah.
anywhere where you're dealing with large amounts of data and need to find efficient ways to organize it, analyze it, and manipulate it.
It's like a superpower for the digital age.
Exactly. And as our world becomes increasingly data-driven, these skills will only become more and more valuable.
Wow. We've covered so much ground in this deep dive. I feel like I've gained
Yeah.
a whole new appreciation for the power and importance of data structures.
It's been an incredible journey. And the most important thing to remember is that data structures are not just these abstract concepts. They're the building blocks that empower us to solve problems, innovate, and create amazing things.
What a great way to put it. Data structures are the tools that allow us
Yeah.
to shape and interact with the digital world around us.
And the journey of learning about them never truly ends. There's always more to discover, more connections to make,
Mm-hmm.
and more creative ways to apply these concepts.
I'm feeling inspired to keep exploring and keep learning. So to all our listeners out there, what's the one key takeaway you want them to walk away with?
I want them to see that data structures are not just for computer science experts. They're fundamental tools that anyone can learn
Yeah.
and benefit from, whether you're an aspiring coder, a data scientist, or simply someone who wants to sharpen their problem-solving skills. Understanding data structures can open up a world of possibilities.
That's a perfect message to end on. It's a message of empowerment,
Mm.
possibility, and the joy of lifelong learning.
And if you're ready to dive in and start exploring this fascinating world, remember those resources we mentioned, like Algo Academy. They're a great place to start your journey.
Thank you so much for joining us on this incredible deep dive into the world of data structures.
It's been a pleasure sharing this journey with you.
We'll be back soon with another deep dive into a new and exciting topic. Until then, happy coding.